Okay, we're going to start solving questions from the exercise. This is exercise 21, question number 1. If you see, there is only one question just before question 1. It says prove the following identities. You're going to prove. This is the question that is given. Secant theta minus 1 by secant theta plus 1 is equal to 1 minus cos theta by 1 plus cos theta. The question is to prove, therefore, you will start with one side and try to get the other side. You will start with the left hand side and try to get the right hand side. The main idea is, when you start with one side and whatever trigonometric ratios are present, change all of them in terms of sine or cos. Okay. That's the simplest way. So, we will start with one of the sides. That's only the left hand side I have written. No need to copy both sides. The left hand side is secant theta minus 1 by secant theta plus 1. That's the left hand side. Okay. I have not written the right hand side. We are going to get the right hand side. Now, if you look at the trigonometric ratio that is here, in both numerator and denominator, you have a secant. Secant is actually reciprocal of cos. So, secant theta can be written as 1 by cos theta. So, this becomes 1 divided by cos theta minus 1 divided by secant theta again is 1 by cos theta plus 1. To simplify this and this, you will have to find LCM. LCM of this is cos theta. So this 1 remains same minus this cos theta has to be multiplied here. 1 minus cos theta. Then this division is here. Again to simplify this, you will have to find LCM. LCM is cos theta. 1 remains the same plus multiply cos theta here. That's cos theta. We got this. And the next step, I am going to change this division to multiplication. So this remains the same. 1 minus cos theta divided by cos theta, and this division is going to be changed to multiplication, which means you are going to write the reciprocal of this, which means the cos theta goes as the numerator divided by 1 plus cos theta. You will see that the cos theta gets cancelled. You are left with 1 minus cos theta divided by 1 plus cos theta, which is your right hand side. You started with the left hand side, you got the right hand side. So this is what is proving. The next question is question 3, again to prove. This is the left hand side, this is the right hand side. So start with one of these sides. It's always better to start with the left hand side. The left hand side is 1 minus cos square theta into secant square theta. So that's the left hand side I have written. Now, if you look at the trigonometric identities which I mentioned, one of the variations of the first trigonometric identity is 1 minus cos square theta can also be written as sine square theta. So 1 minus cos square theta becomes sine square theta into secant is the reciprocal of cos. So secant theta is 1 by cos theta, but this is secant square theta, therefore it is 1 by cos square theta. So secant square theta is 1 by cos square theta. Multiply both of them, that sine square theta into 1 is sine square theta by cos square theta. Look at this. This is sine divided by cos. Sine by cos is tan, but there are squares. So sine squared by cos squared is tan squared. So this can be written as tan squared theta, which is your right hand side. Next. This is the third question. Again proving. This is your left hand side is equal to right hand side is here. So we will start with the left hand side. The left hand side is cosecant theta by cosecant theta minus 1 plus cosecant theta divided by cosecant theta plus 1. That's only the left hand side. If you look at the two fractions which are here, the numerator here is cosecant theta, the numerator here is also the same cosecant theta. So this becomes common. You are going to remove it. So cosecant theta is common, that I have removed. Now to write the rest, I have removed only the cosecant theta which is common in the numerator. Nothing is common in the denominator. Okay. So cosecant theta in the numerator is removed, that's common. Now to write, if this is removed, 1 is left, that's 1 by cosecant theta minus 1 plus cosecant theta was removed, which means 1 is left divided by cosecant theta plus 1. Now to simplify this, you will have to find LCM. So cosecant theta remains the same, and then LCM. is cosecant theta minus 1 into cosecant theta plus 1. Both of them put together is the LCM. So this has to be multiplied with cosecant theta plus 1. So multiply this here, that's cosecant theta plus 1, and this has to be multiplied with cosecant theta minus 1. So plus cosecant theta minus 1. The plus 1 and the minus 1 will get cancelled. Now divided by this, that was the LCM. Next, cosecant theta is here. Cosecant theta plus cosecant theta is 2 cosecant theta. It's like adding x plus another x will give you 2x. Same way, cosecant theta plus cosecant theta is 2 cosecant theta divided by. Now if you look at the denominator, this is in the form a plus b and this is a minus b. A plus b into a minus b, which is a squared minus b squared. A squared is cosecant square theta minus b squared is 1 squared, which is 1. Next step, multiply this cosecant theta with this cosecant theta. 2 cosecant theta into cosecant theta is cosecant square theta divided by, according to the third trigonometric identity's variation, cosecant square theta minus 1 is cot square theta. So this I am going to change in terms of sin and cos now. Okay. So 2 is there into cosecant is reciprocal of sine. So cosecant square theta is 1 by sine square theta divided by, this division is here. Cot is actually cos by sine. So cot square is cos square theta by sine square theta. In the next step, I am going to change this division to multiplication. So this will remain the same. 2 into 1 by sine square theta. This changes to multiplication, which means I have write reciprocal of this. Sine square theta comes out, cos square theta goes down. Now to cancel, the sine square theta and the sine square theta gets cancelled. The 2 is left into 1 by cos square theta. 1 by cos is secant, but this 1 by cos square, therefore it is secant square theta. So 2, this is secant square theta, which is your right answer. And the last question for today is this. Question number 16 is to prove tan A plus tan B by cot A plus cot B is equal to tan A tan B. The normal procedure was change everything in terms of sine and cos. But look at this carefully. If you look at the right hand side, whatever you require, on the right hand side, you have tans. And on the left side, the numerator are already in terms of tan. Only thing is the denominator is in terms of cot. So don't change them in terms of sine and cos. Instead, change everything in terms of tan, because you require everything in terms of tan. So this is the left hand side I have written. Numerator remains same, tan A plus tan B, that's there. Cot is reciprocal of tan, 1 by tan A plus cot B is 1 by tan B. To simplify this, you will have to find LCM. So this I have written same, that is not changing. Divided by, this division is here. Now to find LCM of these two, tan A tan B is the LCM. So this has to be multiplied here, that's tan B, plus this has to be multiplied here, that's tan A. In the next step, I am going to change this division to multiplication. So tan A plus tan B remains same. This is going to change to multiplication, which means I write reciprocal of this. This comes up, this goes down. That's tan A tan B divided by tan B plus tan A. If you look at both of them, both these are same. We can cancel. So you are left with tan A tan B, which is your right answer. And the homework for today is exercise 21, question number 2, 4, 5, 9, 15 and 19.